Hello, Algebra 2 Honors. Today we're going to take a look at section 6.3, which is all about computing values of trig functions of acute angles. Up to now, we've been finding the values of trig functions of an acute angle, which we've been calling theta, where we never knew what theta was. Typically, we were only given one or two values of a trig function of an angle, and from there we used our identities or drew right triangles and used our definitions to find the values of the rest of the trig functions. For today's lesson, however, we're going to take a look at the value of the trig functions of an acute angle, where this time the angle is actually going to be given, okay? So before we get started with the lesson, I want to do a quick recap of some of the concepts that we've talked about. So I'm going to draw a right triangle here, label this acute angle here theta. Let's label the sides A, B, and C. Hopefully by now we're very comfortable with these acronyms. So TOA, sine of theta, right, is opposite of our hypotenuse, which is B over C. Cosine of theta is adjacent of our hypotenuse, which is A over C. And then tangent of theta is opposite of adjacent, which is B over A. And then we learned about the other three trig functions, right, which were cosecant of theta, which we learned was the reciprocal of sine. So this will just be hypotenuse over opposite. And then we learned about secant of theta, which was the reciprocal of cosine. This would be hypotenuse over adjacent. And then we learned about cotangent of theta, which is the reciprocal of tangent, which would make this adjacent over opposite. The trick that I use to remember that sine and cosecant are reciprocals of each other is to know that their first letters are different. The same rule can be applied to cosine and secant, right? Their first letters are different. And then tangent and cotangent are easy to remember because they both have tangent in their names. If you also remember, we talked about degrees and radians, right? We talked about how 180 degrees is the same thing as pi radians. Make sure you remember this, right? And how to go from degrees to radians and radians to degrees. And we've been using the Pythagorean theorem a lot, which you probably remember, but I want to go over that again real quick. So let's get started with the lesson. I'm going to leave about 3 spaces blank here because I'm going to come back later and write something here. So leave some space on your notes as well. And we're going to be looking at the trig functions. So the first angle we're going to be focusing on is pi over 4. If you convert this into degrees, you'll get 45 degrees. All I really did was I did 180 divided by 4. So what we're going to do is we're going to first draw a right triangle. And the first triangle that we're going to be looking at is a triangle that you studied in geometry. It's called the 45-45-90 triangle. It gets its name because those are the angles of the triangle, right? You're going to have a 90-degree angle, and you're going to have two 45-degree angles. And if you remember in geometry, right, when two of the angles of a triangle are the same, then we can conclude that the two sides corresponding to those angles are also congruent. So what we have is an isosceles right triangle. So I'm going to label the side lengths 1. We'll talk later why it doesn't matter what you label the side lengths. And I'm going to call the hypotenuse C, and let's find C real quick using Pythagorean theorem, right? So a squared plus b squared equals c squared. You'll get 2 equals to c squared. So I know C is just rad 2. And then from there, what we're going to do is we're going to find the trig functions at pi over 4. So once again, I'm just going to write this somewhere here. So TOA, just to, again, remind myself how to find the first 3 trig functions, right? So then let's look at sine of pi over 4. That's going to be the first acute angle, right? Sine of 45 degrees is the same thing. This is just opposite of hypotenuse, which will give us 1 over rad 2. We got to rationalize the denominator, and if we do, we'll get rad 2 over 2. So sine of pi over 4, which is the same thing as sine of 45 degrees, is in the end just equal to rad 2 over 2. So now we're going to look at cosine of pi over 4, which is the same thing as cosine of 45 degrees. Cosine is adjacent of our hypotenuse, which is 1 over square root of 2. Once again, if you rationalize this, you'll get square root of 2 over 2. And so cosine of pi over 4, which is the same thing as cosine of 45 degrees, is in the end just square root of 2 over 2. Let's look at tangent of pi over 4. This is going to be the same thing as tangent of 45 degrees. Tangent, you can think of it as sine over cosine. So let's try that. Sine of 45 degrees over cosine of 45 degrees. What is sine of 45 degrees? Well, we just found it above there, right? It's square root of 2 over 2. What's cosine of 45 degrees? That's also square root of 2 over 2. Here, you're just taking a number and dividing it by itself, which means that I know I get 1. And let's color this purple. So tangent of pi over 4 is equal to tangent of 45 degrees, which in the end is just ultimately 1. By the way, if you just used opposite over adjacent, you'd have got the same answer. Now let's look at the other three trig functions, right? So let me zoom out a little bit more. So at this point, I want you to find cosecant of pi over 4. I want you to find secant of pi over 4. And I want you to find cotangent of pi over 4 using your identities, using whatever you need to use, okay? Just don't use a calculator, please. So pause the video, and when you're ready, press play. So cosecant of pi over 4, which is the same thing as cosecant of 45 degrees, this is equal to 1 over sine of 45 degrees, right? Using my reciprocal identities. This is equal to 1 over, now for sine of 45 degrees, I'm going to use this value right here. This is going to make things a lot easier when I take its reciprocal, because 1 divided by 1 over square root of 2 is really just square root of 2. So hopefully you got cosecant of pi over 4, which is really just square root of 2 in the end, okay? For secant of pi over 4, I know that's the same thing as secant of 45 degrees. This is the same thing as 1 over cosine of 45 degrees, right? Look at the first letters, how they're different. Cosine of 45 degrees is also 1 over square root of 2. And when you simplify this, you get square root of 2. Hopefully you guys are 2 for 2 right now. Let's see how you guys did on the third one. Cotangent of pi over 4. This is the same thing as cotangent of 45 degrees, which using our reciprocal identity, this is 1 over tangent of 45 degrees. And we said tangent of 45 degrees is 1. So this is just 1 over 1, which reduces down to 1. So cotangent of pi over 4, which is equal to cotangent of 45 degrees, is ultimately just equal to 1. And so these are the values of the trig functions evaluated at 45 degrees. Make sure you memorize all 6 of them and understand where they came from, right? How we use this right triangle here, right? This 45, 45, 90 triangle to find all the trig values. Now, one thing I do want to mention before we do a couple of examples. So I mentioned earlier how it didn't matter that I called this side 1, 1. I didn't really go into details for that. So I'm going to briefly talk about that right now. So before I do that, I want to write a little note here. Then I'm going to talk about it afterwards. And so what this means is that it doesn't matter how big or how small the triangle is. The value of the trig function at an angle will depend only on the size of the angle itself. So you can have a much bigger triangle that's also a 45, 45, 90. Or the side lengths can be like 5, 5. If you use Pythagorean theorem, you'll get 5 radical 2. And suppose I want to find sine of 45 degrees. If I took opposite of hypotenuse, right, I'd get 5 over 5 rad 2. And if I simplify this, I'll get 1 over square root of 2. The 5's will reduce. And if you rationalize this, you'll get square root of 2 over 2. And so what you notice is you get the same value that we got earlier when we looked at this smaller triangle, right? You still get square root of 2 over 2 here. Similarly, if I found tangent of 45 degrees, let's say, here I'll just do opposite over adjacent, right? I'll get 5 over 5, which is 1. And if you look at earlier, when we found tangent of pi over 4, right, we also got 1. And so what this statement is saying is that it only depends on the size of the angle. So even though this triangle here is bigger than this triangle here, if you notice when you evaluate the 6 trig functions at 45 degrees, you'll get the same answer regardless, right? So it's not the size of the triangle that matters, it's the size of the angle itself. And so let's go and look at a couple of examples, and then we'll be done with the first part of section 6.3. Find the exact value of each expression. There will be no use of calculators here. The whole goal is to practice using these 6 values, right? Which hopefully you have them memorized, or you'll have them memorized eventually. And you'll be able to do these problems much quicker, okay? In the beginning, it's going to be a little bit slow because you're still getting used to knowing these 6 values. But let's see how this goes. So starting with number 1. Sine squared of pi over 4 plus cosine squared of pi over 4. So in order to do this, you have to know what sine of pi over 4 is. And if you remember, this is square root of 2 over 2. And cosine of pi over 4 will also have the same value. So that's what's nice about this 45-degree angle. So plugging it in, what I want to do is I'm going to take square root of 2 over 2, square that, plus square root of 2 over 2 and square that. If you simplify this carefully, you should get 2 over 4 plus 2 over 4, which in the end is just 1. And that's the answer for this first question. By the way, you could have done this problem without doing any work. If you remember your Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1, I could have just noticed that, hey, this whole thing has to equal 1, right? Because this statement here is true for any given angle theta. All right, let's look at another example. Here we'll do cosecant squared of 45 degrees. And we're going to multiply it by cotangent of 45 degrees minus secant squared of 45 degrees. I want you to try this on your own. As usual, press pause, and when you're ready, press play. So cosecant squared of 45 degrees, right? Cosecant of 45 is square root of 2. So that's the value you want to square. Cotangent of 45 is just 1. Minus, and then secant squared of 45, you're just going to square square root of 2. From here, you're going to just carefully simplify it. This will become 2 minus 2, and this should be 0. So make sure you review these 6 trig functions and their values at 45 degrees or pi over 4 radians. Also, to make your life a lot easier when it comes to memorizing these 6 values, if you remember our discussion on complementary angles and how we talked about the cofunctions of complementary angles are equal, we can use this fact here, right? Because 45 degrees plus 45 degrees is 90 degrees. And so if you remember, sine and cosine are cofunctions. So it's no surprise here that sine and cosine have the exact same value, right? If you also remember, secant and cosecant were cofunctions of each other. There's no surprise that secant and cosecant of pi over 4 are both radical 2. And lastly, we talked about how tangent and cotangent are cofunctions with each other. And if you notice, they have the same value there, right? So use your cofunctions to your advantage, because if you memorize 3 of them, you'll be able to memorize the other 3 as well, right? So make sure you review this content and you feel okay with these values and how to find them before you move on to the next lesson.